Hi guys, Heinrich from Shadow Wars here. Last time I showed you how to get the low world bounds and the upper world bounds, and I also showed you how to spawn the sphere at random location, or rather move it to random locations within our sphere. But I also mentioned that there's a slight problem with the approach we took last time, and that is if we move this camera, the entire system will break apart. Let me just show you what I mean by that. So the first thing, let's play this, and you'll see we have our lower bound, we have our upper bound, and our sphere move quite nicely within our view here. But if we, for example, move this camera, so now let's just move it up a little bit, and then rotate it 90 degrees, and we try to play it now. And if we play it now, the borders are no longer in the right place, and our sphere seems to disappear, and when it appears, it seems to appear always on this horizontal line in the middle. Now the reason for that is the initial approach assumed that it was always on a horizontal plane. Let's actually do it in the view like this, and then we can just shift F1, eject from it, and you'll see it kind of is always on this plane. You see, which is not correct, because it's actually supposed to be on the XY plane, and not on the it's supposed to be on the XZ plane and not on the XY plane. So we're basically gonna have to fix that it will always be on the view of the camera itself. So, but before we start with that, I just would like to mention that all of this comes from a little game I've created called Spot the Dot, and if you guys are interested, I'll leave a link down below where you can find it, and it's available on Steam or Android. Okay, so let's just stop this and reset everything back to where it was. So 0 0 0 0. Okay, yeah, let's leave it like this. Okay, now the first thing that we need to do is figure out how we're going to keep the upper lower bounds and actually the spawning within the screen, regardless of where this camera is pointing. Now, to do that, let's go to my little Photoshop page, and let's assume currently that we're working on a XY plane like last time. Now last time we said we just work on XY plane, so we calculate from the camera's location to the left on the X plane, for example, and then down on the Y plane we got our bottom piece here, and it's did the same there. However, there's another way that we can use that will actually work better even if we rotate the camera, and that is by using the camera's forward vector, right vector, and up vector. So what that will entail basically is, regardless of where the camera is pointing, the forward vector will always be forward. The up vector will obviously always point up relative to your camera. So if this is your camera, it will point forward, will point that way, up will point that way, and right will, in this case, will point to the camera. So, and regardless of how you point this, it will always be the same relative to the camera, to the camera. This is my camera, and it will then always move where you want it to be. So this is basically what we're gonna do. So let's do that. So we're going to go to our camera actor, and the first thing we want to do is get the actor location, because that is going to be our reference point. So what we want to get is that location. So it's going to be the same as you have your camera here and you have this point here, and it's going to be that point that we always wanted. Okay, and from there we're going to use the right vector to move, basically just like this. We're going to move back and then down, so we're going to get that point, and that will always be correct depending on where your camera is facing. Same with the up vector. Okay, so let's go and do that. So we're going to get our camera actor location. So get actor location. Oh no, that's not the actor location. Let's try that again. There you go, actor location. And now just quickly what we're going to do, I'm going to go back to Photoshop just to give you an idea of what we're basically going to do. And that is, if we can get my pencil again, is, so we have our little camera or our actor location there, and that's a vector point. And what we're going to do is we want to go to the left and then we're going to go down. But what that actually is just a vector pointing to that location with a certain length, and a vector pointing in that direction with a certain length. So if you want to get to that point, you're just going to add these vectors. So you're going to have your camera actor, and then you're going to have a vector, and this would be actually the camera right vector, but because the right vector actually points to the right, we're just going to multiply it by -1 so that we can go to the left to this spot. So multiply it by a certain length, and I'll show you the length now. Then here is going to be the same thing, so we're going to use the up vector, which is actually to the top, but if we multiply it by -1 we'll go down, and then again the length will get us to this point, and this is going to be our lower world bound, and we're going to do the same for our upper world bound. So let's quickly do that. So we have our camera, our actor location, and we're going to feed that into another vector. Actually we're going to add a vector to that, so let's just add another vector, and that is going to be our the negative of our right vector a certain distance. Now the distance what we want to take is basically our y extent, because regardless of where it's pointing, we've already determined the distance from the center to basically the edge of the screen, and we're going to use those same distances. So to the edge of the screen and to the top of the screen is going to be its individual sizes that we've already calculated. So we're just going to use that again. So first, to get the right angle, we take our camera component, and from that we're going to get our right vector, but we want to set the magnitude to the left, so we're going to multiply this with a float, so it's a scalar multiplication, and the distance what we're going to use is our y extent in this case. But remember, because we want to go to the left and not to the right, we'll have to make this distance negative, so we're just going to multiply this by -1, and then we're going to feed that in there, and we can feed this result into our vectors. Now we have our left point, but we still need to go down. So for that we're going to take our x extent. Again, instead of going up, we're going to go down. Actually, before we do that, we're still going to use that, but what needs to happen is we need to get the camera's up vector. So we're going to take the camera, going to say get the up vector, and again we're going to multiply that by a scalar value, which is going to be the y extent, and again it needs to be negative, so we're going to multiply it by -1 and feed that in there. Okay, need to add a pin there, so we can just feed that in there, and then this result, let's just move this a little bit to the left, we can actually feed in here instead of our original thing, and that is our lower world bound. To get the upper world bound, it's actually quite easy. Instead of going left and down, we actually now go right and up. So to do that, just gonna copy that, paste it in here, remove our inversion, let's move that there, and then again just replace the old one with this one, and there you go. So to do a quick test, we can actually run this. If we run this now, we'll see we still have our borders. Let's just make it like this, then the perspective is correct, and we have our border. So this appears to be correct. Now I'm not going to move this now. Let's just get the spawning right, and then we can move it and play around and see how it looks. So let's adjust our spawning of this object. So let's go here, and we can now go to our random location, and we're gonna adjust this piece of code. So again, we're gonna use our camera's upright and forward vectors to calculate that, but what we're going to do now is we have the lower world bound. I think let's use the lower world bound as our starting point to determine where it's going to be on the random, I want to call it the random right vector of the camera and the random up vector of the camera, because obviously as your camera moves, it's always going to be randomly on your right vector and then randomly on your up vector, depending on even how you move it, how it's going to point. Okay, so first thing we need to do then is we need to get our lower world bound. So we're going to get that, if I can see that, there you go, and from there we need to move a random amount on our right vector of the camera. So we need to get the camera right vector again, so let's get that. So camera get right vector, and we need to move a certain distance to the right vector with the right vector. Now the thing is, we need to keep in mind that just like the previous example, I just want to clean up my screen a little bit. So let's just do that quick. So there's to give you an example, let's say this is the size of our screen. Okay, there you go. A little bit crooked screen, but that's okay. Now if you remember, we added a little bit of padding in the camera. The reason for that, I just want to clean this up a bit. There you go. The reason we've added a little padding there is that if our sphere spawn right at that edge, it's actually gonna clip the screen. So we added a little padding so that the sphere will come close to it, and you can control that padding, and this will also allow you to make the size of your screen a lot smaller, and then you have it spawn on that place. Okay, so we still need to keep encounter our padding here. And the way that we do that is by reusing our X padding and Y padding. Okay, so now first thing what we need to do is we need to take our lower world bound and add it, or add to it our vector that we're going to create on the camera's right vector. So we can basically, so what we need to do is we need to multiply this to get the size of the vector. So we're going to multiply this with a float, and the size is now going to be the random value. And the minimum value is going to be that padding that we've added. So we can use and our y and x here is actually, the y is always going to be on our right vector and the x is always going to be on our up vector. So for the right vector we're going to use our x padding, and we can add that in as the minimum. We can actually add that in there, and that we can add to our lower bound, so we'll get our random value on our y right vector of our camera, depending on, doesn't make difference where it is. Okay, so that is going to be our minimum value. The maximum value is going to be our y extent, but remember the y extent is from the center point of the camera out to the edge of the screen, or the distance on the right vector to the edge of the screen, but we need to double it because we want it to go to full screen. So we're going to take this and we can multiply it by 2. Okay, but we don't want it to go all the way to the edge of the screen like I showed you. We don't want it to go halfway out of the screen, so we still need to add that little padding at the end as well. And that is why we then take this value and we subtract our padding value here, and that is going to be our maximum value. Okay, and that is the random value on our right vector. So now we need to calculate the random value on our up vector. So the way that we're going to do that is get our up vector, and then we're going to do the same as here. So we might as well just copy all of this, except this part. Now we can yeah, except this part we can add it in there just now. So we still need to multiply it, so let's just add that multiply there with a float, and that goes in there. Oh yeah, it's x vector, that is still fine. This actually needs to be our x padding and expand, so we're just gonna add that in for the minimum and for our subtraction, and then also our x extend for our vector on the up vector direction now. Okay, and then let's just fix this because I'm OCD a little bit. Anyway, okay, so now that we've done that, we can then just add this to that vector as well, and with that we have all the possible random values always on that plane, depending regardless of where it's pointing. Okay, so let's add that to our output instead of the original one, and that should do the trick. So let's first just check if it works on our normal screen. So if we play it, we have our upper and lower bounds, that's still there, and it appears to be working fine. Now let's do the other test where we take our camera, let's move it up a little bit, and let's rotate it. Let's do the 90 degrees test again. So let's see how it looks like now, and if we play it now, there's that one, there's your lower bound, and now it appears to be in our bounds as always. Okay, and just to do another test, we can actually, let's rotate it like this, just halfway, and if we play this, it is skewed, but how do you know it's skewed? Well, let's change it a little bit more. So let's take this and move it enough that it is, you can see a part of the plane below. Play it now, it is skewed, but we still have the correct coordinates, and this appear to be on the right plane. And there you go. Awesome. Okay, so that's it for this little tutorial. If you like this and want to see more of this, you can wishlist. No, not wishlist. You can subscribe and hit the notification bell, and when the next one comes out, you'll be the first to know. Anyway, cheers. See you guys next time.